Hello, welcome everyone. Really excited to have everyone here. I see a lot of people trickling in. As we have everyone coming in, maybe just real quick in the chat, drop where you're dialing in from. And to kind of get started, obviously, I know you're here to listen to Marie discuss, GMAT and GRE, but we at the Leland team have built boot camps, and we have a free giveaway for our upcoming boot camp that we're hosting. A boot camp, which we'll go more in depth on later in the call when we take a break from the Q&A in the session, is, opportunity to listen to coaches, get one-on-one training, access to resources. But what you need to do is scan the QR code right here at the bottom or tap it in your browser bit.ly/GMAT giveaway. And one lucky person in this call will have the ability to win a free admission to the boot camp. And then everyone else will also be able to get it for a discount, which is something that we'll be able to dive into a little bit more. But just want to make sure everyone scans that QR code and applies, and we'll chat about it a little bit more deeper in the call. But then from there, I'd love to turn it over to Marie to obviously talk about, the GMAT and the GRE. So I'll unshare my screen and let you take it away, Marie.
Okay, great. Does it let me do it now? Okay. Okay, looks good. Okay, hold on. Give me a sec. Okay, we see this screen, right? Integer properties.
Yep, we can see it.
Okay. I just want to make sure that before I start,
Yes, of course.
everything's good. Okay. Hi, everyone. My name is Marie Bursick. I've been a tutor for about 20 years, starting off with SAT, ACT, GMAT and GRE, and LSAT. I used to do that for a while. And I was a high school teacher in my past life. And for the last 8 years, I've been doing GMAT and GRE exclusively. I've been with Leland for about 3 or 4 years right now. And what I'm about to show you, or what this lesson is about, is I've created my own curriculum for GMAT and GRE, taking from things that I've learned. I mean, I've worked with a lot of different, I've had access to Manhattan Prep and Target Test Prep and Magoosh and Kaplan and all these different things. And quite honestly, like some of this comes from, I think that I was always in high school, I did a lot of contest math. And I feel like I always had a sixth sense for how these tests work and how they think and how they're written and like the subtleties between all of them. And also, this is kind of like this came together from a lot of my high school teaching as well. And a lot of this stuff is actually from like a seventh grade class. I mean, because I always think that this test is like middle school math on steroids. So I want to show you how, I mean, my first lesson is always my first lesson, and I'm showing you my approach to how I look at numbers. And my belief is that to teach students, they need to have a very, very strong arithmetic base. And a lot of times when I'm teaching my students is not just the algebra and all the different concepts, not like rate times time distance, but every single thing I teach comes from a really strong arithmetic foundation. And that's based all on this idea that I call number caterpillars, which is really sort of prime factorization, but it laces through everything because it makes you so much faster at reducing fractions, seeing patterns, sort of seeing through numbers. And it's basically a new way to look at numbers. So what we're going to start off with, I just, this first lesson, usually when I'm doing it one-on-one with the student, I can gauge, what they're getting, what they're not. And I know that I'm presenting to a group, so I'm trying to keep this a little bit slower pace. And this is I think about 40-50% of what I do in my first real lesson, just again, because I can't go too hard and don't want to lose anyone, which we'll see. Okay, so the first thing I usually ask my students, I'm just going to give you guys a minute to, I would ask you to write the prime numbers, okay? I'm sorry, the first 10 prime numbers. So prime numbers, if you need a reminder, are numbers that cannot be, the only factors of prime numbers are one in itself. Um, and I'm going to start by saying one is not a prime number, and two is the first prime number, and then three. Okay, so hopefully that like gets you started, but two, three, keep going until you have 10 of them. And I do like if people can just drop in the chat, and let me find the chat, and I can see I just kind of need people to go done, 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 so I can kind of go along and not lose anyone. Okay, looks good. Okay, so I see, okay. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are your first 10 prime numbers. I always say 2 is like the celebrity prime number because it's the only even prime number. So when you're looking through prime numbers, never check evens. It's the only one. Later on, when I talk about odds and evens, which is usually my second lesson, I bring up the concept of like it being the contaminant and how it contaminates a number to make it even. Okay. And then odd numbers are always, a string of odd numbers remains odd if you're multiplying them. Okay. So I want to go over I'm going to teach you how to do the greatest common factor, the lowest common multiple in this way that I kind of really did learn in seventh grade. And I just want to remind you of some vocabulary. So starting over here, factors of 12. Factors are numbers that fit inside, and factors are finite. And if I ask for all the factors of 12, I always ask my students to do this like outside inside method where you go 1 times 12. 2 times 6, 3 times 4. And since there's nothing between 3 and 4, these are the factors of 12. There are 6 positive unique factors of 12. Multiples of 12 are infinite. Okay, and multiples of 12 are 12 times any integer. So 12 times 1, 12 times 2, 12 times 3, so on and so forth. And this goes on for infinity. And technically, 0 counts as a multiple of anything, but this is a technicality that really works for divisibility rules, which I am going to get into today. Okay, so I wanted to remind you a little bit about the concept of greatest common factor and lowest common multiple before I show you this trick that I learned, or this thing I learned how to do this in seventh grade. But a greatest common factor always pushes that way, and a lowest common multiple is pushing this way. We never find something like the lowest common multiple. I'm sorry, we never find the lowest common factor because it's 1. And we never find the greatest common multiple because that's infinity. And this is just like a little example. The greatest common factor of these 3 numbers is 4. 4 is the greatest number that fits in all 3. The lowest common multiple of these 3 numbers is 48, meaning that all 3 of these numbers fit into 48, and 48 is the smallest thing that they all fit into, because they all fit into 480, for example, or 48 million. Okay. So that's to remind you what this is. Now let me talk about what number caterpillars mean. Okay, so basically, when you think of integers, every integer is made up of prime numbers. And I think of prime numbers a little bit like elements on the periodic table. And I have this thing that I make my students do, which I make them like sort of color all the different prime numbers, and I make them do the prime factorization of every number from 2 to 100, like this. Okay, this is one of my students' caterpillar charts. Okay, she had an iPad, she did this all, and I've used it ever since to explain like what the assignment looks like. Okay, and let me explain this caterpillar idea for a second. So when I first started teaching SAT so long ago, I remember thinking like, this is how I would think about this, is that, H2O is oxygen and 2 hydrogens, okay? And in the beginning, I used to call these number molecules. Number 12, when you do those factor trees, 2, 6, 2, and 3. The number 12 is 2 times 2 times 3. And I felt like I used to call them number molecules. And then there was a time when I was teaching sixth grade and seventh grade, and it turned into caterpillars, okay? The idea of just going like this, okay? That's the idea. That's why I call them that. I never do that. But when I say number caterpillars, I don't know what screen you're talking about at DTL. I didn't have that one with the one, but at the end, there's going to be something that that will come up. Okay, so anyway, called them this is the idea of number caterpillars. It's the number caterpillars. If I was talking to a math teacher, I would just say it's the prime factorization of the prime factorization of any integer. Okay, so 18 is 2 times 9. So 2 times 3 times 3. And 30 is 2 times 15, so 2 times 3 times 5. And I do them on the fly, and sometimes my students are like, "Can I just do the factor trees?" And absolutely, but I've been doing this for so long, it's kind of second nature. So when my students do color them, the idea is that like they pick a color for 2, and all the 2s would be the same color. And it might seem like a silly little really one of the two of the hardest subjects are probability and combinations. That counts as one, and integer properties, and and roots and exponents, and all of those things deal with this. So sometimes people, I don't know, I know that I have to tell them over and over, when my students always need to have 4 things: a notebook, a formula guide, the caterpillar, and a cheat sheet. And I can't tell you, like, very often I have to make them look at this caterpillar to see certain patterns and make certain observations. And yeah, I mean, I also like, that it's pretty. It makes it, math is not always like so fun, but I think it's amazing. Okay. So, greatest common factor. Oh, I want to say one more thing. Why is 1 not a prime number? Okay. 1 is not a prime number. It's like the lack of prime numbers or the empty set of prime numbers. And the reason is every integer, like 12, has a unique makeup. 12 is 2 squared times 3 to the first. Like that's its H2O, okay? And 18. I could put a 1 on here and it's still 12, and another 1 and still 12. So 1 is not a building block number, and that is why it doesn't count as a prime number. Another way, also, I mean, you could say prime numbers all have 2 factors. Like 13 is, these are the 2 factors, 1 in itself. 1 only has 1 factor itself. Another thing I think about is when you think about calling a number an integer. For example, if you said make 12 a fraction, it's 12 over 1. And for a number to be an integer, when I think about if it says, something is an integer, it means that there is, after all the canceling out, that there is nothing on the bottom. So we know that 12 is divisible by 6. And I think we all know that that just is equal to 2. You'd think of it like that. But I think of it as 2 times 2 times 3, and 2 times 3. And that 2 divided by 2 is 1. And this cancels out. And so I just have a 12 over 1. It's important because sometimes there are questions that say if blah, blah, blah is an integer. And I need students to realize that what that means is that when you're looking at a fraction, all the pieces on the bottom will be canceled out by pieces on the top. So that's a little bit about like why 1 does not count as a prime number. It kind of comes through, and I mean, I think people can kind of accept that. But anyway, this is again all about integer properties. Okay, so how do you find the greatest common factor of 3 numbers? The lowest common multiple of 3 numbers. Think about the words common factor, common things that fit inside, and the greatest amount of common things that fit inside. So you can say, look, they all have a 2 and they all have a 3. And therefore, the greatest common factor is 2 times 3, or 6. I'm trying to use easy numbers that, kind of ring true. I just have to erase that for my next part. So 2 times 3, okay? 6. The greatest common factor of 12, 18, and 30 is 6. Now, I want to mention that if there was another 3 here and there was another 3 here, I would have added another 3 to the chain and said 18. I'm saying this because sometimes people don't realize that they can double up on the same prime number. Okay, you can have 2 3s in your greatest common factor. You can have 2 of the same prime number. Okay, the lowest common multiple. There's so many different ways that I teach this because I don't know which one's going to work the best, but I start off by saying it's a little bit like the mama caterpillar. Okay. And let me go over here for a second. Remember when I was doing multiples of 12? Like 36 is 12. So 2 times 2 times 3 times 3. Okay. It has 12 in it. 48 is 2 times 2 times 3 times 2 times 2. When I'm thinking about a number being a multiple of another number, I only think in prime numbers, only in prime numbers. And for something to be a multiple of 12, it has to have the pieces of 12. For something to be a multiple of 18, it must have all these beads represented. This metaphor changes. It's going to be beads in a necklace store at a craft store at some point. Um, and earrings and little things when I'm talking about different types of problems. But the mama caterpillar, she basically needs to have all three of these. She wants, these are her kids, and she has to have them all in her kangaroo papoose. Okay. Her all in her, again, this metaphor. So I'm going to make a chain, a caterpillar chain, and I'll pretend like I don't know how many bubbles are there. And for this number to be a multiple of 12, it has to have two twos and a three. Okay, this kid's been picked up. Then you go to 18. 18 has to have one, two, and there already is one, two here. And there has to be two threes, and I have one, three, and I'm only going to put one more because you're trying to, like, she's picking up the kids, but she wants to be as light as possible. So you don't want to have extra beads in here because, again, this is the lowest common multiple. And then 30 needs one, two, got it, one, three, got it, and I need a five. Okay. So now let me just again kind of color code this so that you can sort the visual seems to even help me, and I know this stuff or see this stuff so clearly. Okay, so as you can see, 12 needs two yellows and a blue. I've got two yellows and a blue. This needs one yellow, two blues. I have one yellow, two blues. And then this one needs a pink, and I have the pink in here. One thing is that these tests really, I'm going to start off by saying instead of certain ways to multiply, these are little arithmetic things. I say don't climb. I don't like when students go 2 times 2 is 4, 4 times 3 is 12. 12 times, I mean, it takes forever. So certain things you should always do is look for twos and fives. These tests love to, like, we work in a base 10 system. So you should always look for twos and fives because that's 10. Then I would just multiply this. 2 times 9 is 18. I have 18 times 10, 180. That is the lowest common multiple of 12, 18, and 30. Okay. That is the smallest number that they all fit into. Where might have you seen this in like high school? If you had something like x over 12 plus y over 18 plus z over 30 equals 1 or something. Sometimes this reminds me of stuff I would teach in trig and calc, and students had to get rid of the fractions. And a very common thing when I'm teaching, juniors and seniors is that they do not know how to find the lowest common multiple. So they just go 12 times 18 times 30. And then everything is huge, and then they're reducing. It's a mess. So knowing the lowest common multiple would help in this situation. And I'm going to show you kind of like, how that layers in later. Okay. So usually when I turn the page, everyone forgets about the lowest common multiple in the mama caterpillar. But remember, you're just sort of making a chain. You don't know what's in it, but you want these things, and you don't want to put extra beads because they can be reused. Like the beads for the 12 can be used for the 18, can be used for the 30. Okay, next page. Okay, so buzzwords for number caterpillars and factoring in general. Okay, when I have certain things that I train my students to know, and one of them is like, what's my favorite number? I get to that. That's 91 for a certain reason. What's my favorite word? Factor. Factor, factor, factor. Factoring is kind of a blanket word, that an umbrella word that means a lot of different things. But I think the thing that has come to mind most recently is, I'm like, if you ever like get a at one of those fancy restaurants, like a deconstructed hamburger where everything's in parts. That's how I think about factoring, as putting things into parts. And factoring starts off with number caterpillars, factoring integers. Then I also think about taking the greatest common factor out. That's another type of factoring. And then these tests love quadratics, sorry, specifically special quadratics. So buzzwords for number caterpillars. Factor, divisor. This could be a verb or a noun. Multiples, divisible. Primes and integers. And a lot of problems that have to do with roots and exponents really are number caterpillar problems. Okay, so let's say you need to do this. This wouldn't be a problem, but find all the factors of 180. Okay, so my first thought is let's do the caterpillar for 180. That's 10 times 18. So 10 is 2 times 5. 18 is 2 times 9. And give me a sec here. Okay, so starting off 1 and 180, 2 and 90. 3 goes into 18 6 times, 3 and 60. I'm just going through all the integers. And right here, I'm going to pretend that you're just one student and you're doing the typical thing. I usually go, does 4 go into 180? And this is what I usually see. I see students go like this. Yes, no, yes, it does. And they eventually figure it out and they do division. And I'm trying to get people away from thinking that. See, I know that 4 goes into 180 because 4 is 2 times 2. And I see a 2 here and a 2 here. So I know that 4 goes in. And it goes in 5 times 3 times 3 times. So 4 times 45. And that's this little trick, okay? That, I mean, just showing you how to look, because I think of when a number caterpillar for me is like looking at an x-ray of a number. And it's way more important for me to know the guts of the number rather than 1 next to 8 next to 0. Okay, so that's how I look at it. Okay, 5. 5 goes in. I mean, I know a lot of people just go, yeah, it ends in 0, but 5 goes in. And again, look at what I'm doing. I'm saying there's 5, and then I'm going to multiply the other parts of the chain. So 4 times 9, 5 goes in 36 times. Okay, 6 goes into this. 6 is an easy one, or it should be, because you should know that 6 goes into 18 3 times. So 6 goes into 180 30 times. And then 7. And 7 is a brand new element, okay, that is not represented here. Okay, so 7's a prime number. You don't see it in there. Nothing's going to multiply to be 7. So 7's not in there. Then I ask 8. And 8 is, okay, 8, I'm just going to say 8 is 2 times 2 times 2. So 8 does not go into 180 because I'm missing a 2. But sometimes there are problems that, like, we'll say something like this, like 180x is divisible by 8. What is the smallest integer x could be? Okay, and the smallest integer would be 2. 180 times 2, if I had another 2, yeah, then I could, take this out and be 45. So it's always like looking at the pieces, okay? And a lot of my students, I had a student who said, I'm starting to think like you. I see 16 as 4 2s, and that's exactly what I want. I want people to see the prime factorization of the numbers. And really, it's 2 to 100 that I concentrate on the most. And I mean, with my students, I put them on this certain game it's my own game. I made it up for like a division, kind of like an Atari game, to make them very fast at division and seeing all the patterns that are most common on the GMAT and the GRE. Okay, 8's out, 9 goes into 18 2 times. So this is 9 times 20. 10 goes in 18 times. 11 doesn't go in for the same reason 7 doesn't go in. It's a prime number. It's not here. 12. 12 is 2 times 2 times 3. So 12 goes in 5 times 3 times. So 12 goes in 15 times, or 12 times 15 is 180. 13 is a prime number. That color is not represented. 14 needs a 7. And now I've closed the gap. And these are all the factors of 180. Okay. And I want to say something about different questions that could be asked. There are questions. This is kind of a hard one, but for harder problems, but there's a question could be, how many factors are there in the number 180? And here there are 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. There are 18 positive unique factors. Sometimes we just put these extra words to qualify. Factors can be negative, but they don't do that on the test. Okay, there are 18 positive unique factors. Another question could be, how many unique prime numbers are there? And there's only 3 unique prime numbers because there's 3 colors here. There is never a question that's actually just about the prime factorization. I mean, never seen, there's one that I've seen in the history of like in the last 8 years that I can think of, but I've never really seen a problem where the answer would be five. The caterpillar helps you solve everything else, but questions usually aren't about the caterpillar themselves. Okay. Okay. The next most important thing that I need my students to know is, of course, I need them to know like multiple, your the multiplication tables and division. And when they're a little weak on that, I have different apps that I have, and then that game that I was referring to. But after this, the next most important thing. Oh, wait, hold on. Before I get into that, I have a follow-up question here. Um, let's see if this was understood. So with the numbers, I would like you guys to find the greatest common factor and the lowest common multiple of the numbers 72, 60, and 96. I'm going to give you guys about 3 minutes to work on this. If you're completely clueless and you're not sure, just caterpillar each number and then you can follow along when I review. And if there are any questions, I'm going to look over here now and what apps do I recommend? Um, Okay, so I don't like people learning your multiplication tables is useless. You should learn your division tables. You should always be able to do it backwards. Factoring a number and breaking it apart is more important. The ones that I like are, let me just look this up. I'll tell you because you have to find the, give me one sec. Oops. Okay, the apps that I like are, wait, Math Speed Drill. Anything that's making you go fast is important to me. It's a bad weasel game. I mean, these are kind of made for kids, but um, they're good enough. I always tell people to skip multiplication, go to division, and go to the hardest setting, okay, which is 0 to 15. Um, the other one I like is division flashcards, and it's by David Villegas. The caterpillar thing, yeah, this is the caterpillar. And if you want to compare, by the way, the answers are here for the caterpillars. But division flashcards, David Villegas. And I always tell people when you go to the settings, select a multiple choice instead of type in. I'm reading off an email that I've sent all my students before. Like when students think that they're weak at this, I'm like, get into this because when people aren't good at their multiplication tables, it's kind of like when you were like in fourth or fifth grade and someone would read in class and you feel like they're sounding out every word. I like it's a must that people have to be able to go back and forward really quickly with your basic multiplication tables. It's kind of like being literate. Okay. Oh, and then okay, wait, more here. Division flashcards, David Villegas. It says Villegas Ventures, but I think that you could find it with his name. And then I always say set the setting to max number to divide 100. So these are the two that I have, and then the other one is my own game, and I have a whole link for that. I mean, I'm happy to share it, but it will take me time to find it. Um, I like these games because they give you like 30 seconds and I like the time pressure. I want people to try to keep upping their personal record. Okay. Um, okay, how are we doing here? Has anyone found the greatest common factor, lowest common multiple? If you have, just say yes. And if you, instead of putting the answer, just so we can go through that. Okay. Okay, cool. I got 3 yeses. Let's all, okay. So 72 has 3 2s and 2 3s. Okay, could also be written in exponential form or like condensed form, I say. I'm sorry, 2 to the third, 3 squared. 60 is 2 times 2 times 3 times 5. 2 squared, 3 to the first, 5 to the first. And 96 has 5 2s and 1 3. Okay, maybe I should have written it all out like that too, to keep it consistent. Okay, so if you look at what they all have in common, they all have 2 2s, because 60 only has 2 2s, and they all have a 3. Where did I go? Oh, that was a 3, not a 5. Okay, so the greatest thing that you could take out of all of them, the greatest common factor, is a 12. Okay, the lowest common multiple, the mama caterpillar, she's got to fit. Think about, I mean, really the longest number. Let's just start with 96. 96 is the longest. It has 6 pieces. All 6 of those pieces have to be present for 96. So start with the longest one because usually that's going to take care of a lot. Now look at 72. 72 needs 3 2s. I have 3 2s. It needs 2 3s. I only have 1. Now I add this, and 72 and 96 are both taken care of. 60 needs 2 2s. I have 2 2s. It needs 1 3. I have 2 3s, so I'm good. And it needs a 5. So now I have to add that 5. So the lowest common multiple, and then I'm going to remind you, the way that I would do this is I'd say 2 times 5 is 10. Okay. And I have 4 2s, and I know that 2 to the fourth is 16. I know that this is 9, and 16 times 9. And 16 times 9 is, I'm just going to say this is 144. So 144 times 10. And the lowest common multiple is 1440. Okay. And right here, just actually, I want to take a little side because there's certain things that I teach on the first day, like how to multiply numbers and how to do long division and multiplication. So if I'm doing a 2 by 2 number, for the GMAT people and even for the GRE people are always like, oh, I get a calculator. I need to learn this stuff, but it's not true. You should always kind of stay away from the calculator. I liken it to a Wi-Fi password that you like type in 3 different times. Your fat fingers get in the way. And also the calculator is really a false crutch because people like, if you're too addicted to the calculator, you don't see a lot of stuff in front of your face. It's a calculator for GRE is really best used for a lot of the pie chart problems where I still don't really need it, but sometimes the pie chart problems because you want to know like what 97 divided by 102 is. And it's really down to a decimal. But I do tell students that what should you like? I have this expression, what's inside the edges of that's outside the edges of the universe or inside like what you do need to know. And if a 2 by 2 number, you should be able to do very quickly. And I set up this chart. So 13 is going to be 10 plus 3, and 27 is 20 plus 7. And I do it this way: 20 times 10 is 200, 10 times 7 is 70, 20 times 3 is 60, 7 times 3 is 21. And then I'm going to add up all the pieces. But before I do, this is an important part about why I'm illustrating this. This box comes up over and over and over in my lessons for factoring. It kind of represents FOIL, but it's going to come up in a lot of different ways. One thing this also shows you or illustrates is that like anytime you are multiplying numbers, if you want to know what the final units digit is, it's going to come from the units and the units. So 3 times 7 is 1. So I know that this number ends in a 1, okay, just from the units digit, because look at how this works out. See how, you've got a bunch of zeros, or this is going to be in the hundreds, the tens, the tens. Only here is where you would get the units digit. Anyway, so 200 plus 130 plus 21. And this is how I would do a 2 by 2 number really fast. Also, you could, be expected to know a 3 by 1, but very rare. I mean, I don't, I almost want to say never, but you never really have a 3 by 2. You'll never have a 3 by 3. So if you're doing that, you should know that's outside the edges of the universe. I shouldn't be expected to do this, and you're probably going about the question the wrong way. That's just a tip off. Like this test is not about making you do a lot of like heavy labor in terms of multiplying 3 by 3 numbers or anything like that. That just would be a tip off that is going the wrong way. And this, I would say, this is 300 times 5 plus, I don't know, I'd say 10 times 5 or 2 times 5 or 12 times 5. And I just go, okay, that's 1500. 12 times 5 is 60. That's how I put it together. Okay. A lot of the stuff I teach you is really probably not what you learned in elementary school. I mean, it should have been phased out by now, but a lot of people are still doing the way that they learned. And if carrying and all that stuff and borrowing, I don't really ever do that. Okay, so moving on past this. Hopefully this, I don't know if anyone has any questions, but I'll be checking the chat. We're going to go into rules of divisibility now, and I'm going to show you some problems that deal with that. Okay. So this is super important to me. I make sure that my students, I have this thing where I make them keep a cheat sheet, and then I do force them to use the cheat sheet on their first practice test, because I want them to start streamlining things that either concepts that they just don't know versus concepts that they've learned, but have formulas that they're still a little, they still need to have like, oh my gosh, the training wheels on. Okay. And rules of divisibility, I tell them, look, this should not even be on the cheat list. You must memorize this right away. Maybe the 11 trick or something. But starting off, let's start off with like the ones that have to do with units digits. I have to separate this because when we get to patterns and remainders, which is definitely the hardest thing that I teach, patterns and remainders, this is a little tricky. So units digits, you know that 2 goes into a number if the number is even. Okay. And you look at the units digit and you can tell if the number's even. You know that 5 goes into a number if the number ends in 0 or 5. And you know that 10 goes into the number if the number ends in 0. Okay. This is what I'm doing, but I believe probably everyone knows these. Then I'm going to go the most important trick, the 3 trick. Okay. The 3 trick is that the sum of the digits is divisible by 3. Okay, now, why is this the most important trick? There are a lot of what I call weird looking odd numbers that if you know most of your multiplication tables, even if you're pretty good and you know everything up to 12 times 12, 13 times 13, there are numbers like 51. Okay, I think of 51 as one. It's a weird looking odd number. A lot of people think it's prime. But the trick for the 3 trick is to say 5 plus 1. 5 plus 1 is 6. And since 6 is divisible by 3, 51 is not a prime number. It's also divisible by 3. Okay. And 3 goes into it. And this is how I do division. I might lose you guys here, but what I do is I don't put anything up here. And I just do a no-brainer multiple, usually a multiple of 10. So like 30. And then I know that 3 goes into 30 10 times. I'm going to put that over here. I'm going to subtract, go 21. I know that 3 goes into 21 7 times, and I'm done. And so 51, the caterpillar for 51 is 3 times 17, okay? And the reason you don't know that is because people don't know their multiplication tables of 17, okay? So the 3 trick, I also point out the 3 trick is very important because 33 or, 33.333, 33% of numbers are divisible by 3. But, again, another one would be like 87. Okay. Sometimes people, yeah, it's not a normal one to know. But 8 plus 7 is 15. And since 15 is divisible by 3, 87 is divisible by 3. And I would do this again and I'd be like, 3 goes into 60. And I know that it goes into 60. How many times does it go into 60? 20 times. And I subtract 27. 3 goes into 27, 9 times. So, and then I'm done. So 87 is 3 times 29. Okay. Now, the 3 trick is going to work for every weird looking odd number under 100 except for one. And that number is 91. Okay. And that's why I say it's my favorite number, because I want people to just remember it. But 91 is 7 times 13. And these tests love 91. They really do. They put 91 in everything. Okay. Because people think it's a prime number and it's not. Okay. And people who know the 3 trick, and I'm not going to teach a rule of divisibility for 7 or 13. There's a rule of divisibility for everything, but sometimes they are just so elaborate, it's not worth the trouble. Okay. 9. 9 is related to 3. 9 is 3 squared. So the trick for 9 is the exact same trick as 3, except the sum of the digits is divisible by 9. Okay? Right around here, I have this, usually do a little fancy thing over here where first day lesson. Hold on, let me find this number. I don't need to make it so elaborate. What is the remainder when 237,941 is divided by 9? Or then like part 2 by 3. Okay. I'm going to take a second right here. This time, if you guys want to throw your guesses in, sure. Hold on. This number, let me just make sure that everyone understands. This is one number. It looks a little sloppy, but this 237,941. It's one number. It does, by the way, have to do very much. I don't need you to do long division. If you are, stop doing that. That's going to be a pain. The best way to do it is, it has to do with this idea of the sum of the digits is divisible by 9. Yeah. Okay. 8 is correct. Okay. For people who are saying 8, you're good. 8 for the 9. And then what about for 3? Okay. Here's the deal. You can add up all the digits, which most people do. They add up all the digits and I can't remember what do I get here? This is how I do it. I knock them off 9 at a time because 2 plus 7 is 9. Then another 9, that would be 18. And now I have 8 left over. Okay. So the remainder when this thing is divided by 9 is 8. And if I want to divide by 3, or if I want the answer, what's the remainder when that number is divided by 3? I know that 3 goes into 8 twice and has a remainder of 2. So this part is 8 and this part is 2. And someone said to me once, like, do you have to do it by 9? And I'm like, no, you could do it by 6. You could do it by any multiple of 3. But sometimes I've noticed that there are a lot of problems that do, like, there's one that says something like X is 943 and Y is 793. And the question is, what is the remainder when X times Y is divided by 9? And the trick is to figure out what's the remainder when this is divided by 9, and the remainder here is 7. How do I know? Because cross off 9, I have 7 left. And what's the remainder when this is divided by 9? Take that. Remainder is 1. And then I just multiply the remainders, 7 times 1. So if you did 943 times 793, and then you divide it by 9, I'm guaranteeing that the remainder is 1, because this number divided by 9 is 7, this one is 1, and then you multiply the remainders. Okay, that's that trick. Okay. Amanda, do you want, you know what? You can, I mean, tell me when you want, and I'll,
Yeah, if we want to take a quick pause, really quick, a
okay,
minute intermission for everyone to get water and take a breather, and Andrew can take over and do a quick pitch really quick, and
sure.
talk about our upcoming GMAT and GRE boot camps. Andrew?
Yeah, first off here, let me go ahead and share my screen. Marie's incredible. So scan this QR code if you want to book some more time with her to get some individual time with her. She's absolutely fantastic, as you can see by her experience and from this session. I was just telling Amanda, I'm like, she's a literal wizard. Like, this is crazy. This is really, really cool. So, if you want, obviously, to go a little bit deeper into GMAT, GRE preparation, this is why we have the boot camp. So again, we had that QR code at the beginning. If you missed it, put this here in your browser where it says bit.ly/GMAT GRE giveaway. And right now I'm going to break down a little bit what we'll be doing for this boot camp. As you'll see here that we'll have 2 separate boot camps, one for each at the beginning of April. So there's time to prepare. But once again, someone tonight will win free admission, and everyone else will be able to secure their spot at a discounted rate just for being here. So a huge breakdown here about the 2 different boot camps, right? You'll be able to see it's going to go very much in depth sessions such as these that are very on hands training, which is pretty difficult to find in terms of live sessions, being able to do these exercises and ask questions with coaches just like Marie. And apart from having these live sessions, we will also have different custom study assignments that you'll be able to get separate. You'll be able to join a community of peers like everyone that's on this call. Coaching discounts, advanced prep material. We have our Leland Plus library. And so normally, as you guys probably know with other rates out there of coaching programs, it could be quite expensive to do something like a boot camp with materials and instruction and prep. But you'll see that here for everyone here today, it'll be a total of $800. Once again, one of you will be the lucky winner and be able to win the scholarship or win free admission to it. But then everyone else will have the opportunity to win this discount on the boot camp. And then from here, yeah, once again, just type this into your browser. And then if you have additional questions, once again, if you're the winner, we'll be in touch with you. If you're not, we'll send you like a quick text or an email, and then you'll be chatting with me directly if you have questions about the boot camp so we can get you included and prepared for it. So if there's any questions, please let us know. With that being said, I'll unshare my screen and give the time back to Marie so she could go a little bit deeper in the last 10 minutes here for additional exercise with y'all.
Okay.
Maurice got 40 more minutes. You've got plenty
Yeah, I'm
more
Oh,
like,
time
I'm
to
my
like
talk.
bad,
back
my
and
bad,
forth.
my bad.
Yeah,
Okay.
our wizard continues on.
I love it. Awesome.
Yeah, okay. Okay, everyone sees my screen. Yeah, and by the way, just so you guys know, I'm going to finish up this lesson and I'm going to take questions about different prep options. I'm going to answer your questions as best I can and give you like, I mean, depending on where your budget is and all that stuff, I'll explain like the whole gamut of that and give you my personal opinion on different options, okay? Okay, anyway, 3 and 9, we're moving on here. The 4 trick. The 4 trick is the next most important. The 4 trick comes up a lot. All this stuff is not extra credit. This stuff is like you need to know this all the time to do this. So the 4 trick is the last 2 digits of the number. The last 2, I always had like struggle to make this grammatically correct. The last 2 digits form a 2-digit number divisible by 4. Okay, now I always say this is magic. Okay, and how this trick works is I'm not going to do a whole proof, but I can very much easily explain how the 4 trick works. So first, let me give you an example. 2,732. If you want to know if this number is divisible by 4, you look at 32. Does 4 go into 32? Yes, 8 times. Therefore, 4 goes into this whole number. Why does this work? Because 4 goes into 100. Right? We know that 4 goes into 100. So 4 goes into any multiple of 100. So I can change this number into 2,700 plus 32. And I know that 4 is always going to go into this. So I just got to look at the leftovers. If 4 goes into the leftovers, then it's good. Okay. Okay. The 8 trick is, I swear, I feel like I've never used it, but I have to teach it because when I do fractions, I like the symmetry. Anyway, the 8 trick is the last 3 digits. It's got to be a pretty high level problem. If my students forget the 8 trick, I actually will forgive them. It's not the most important. 11 is more important. Okay, so 6. Sometimes I'd like to do 6 in a different color. I'm going to give you a little hint and say that I'm going to have a problem coming up, and this is related. Okay, not that I don't want to give away too much. You're going to have to think for yourselves. But 6, the reason I'm changing the color is because 6 is not a new trick. Okay, 6, the caterpillar for 6 is 2 times 3. So when I need to know that a number is divisible by 6, I check that the number is even, and I check that the sum of the digits is divisible by 3. A good example, look at this number, 1,002. Okay, it's even. When I add up these digits, I get 3. Okay, they don't have to add up to 6, they add up to 3. And therefore, I know 6 goes in here. I'm going to go 6, start off with 600. I know that 6 goes into 600 100 times. Then I'll go 402. The reason that this way works better than the way that we do in high school, for the most part, is that if you screw something up, like if you could either put 360, or sometimes people put 300, and this will take maybe one more step, but you won't get it wrong as long as you subtract correctly. So if I do 360, I know that that goes in 60 times, and I subtract 42. And I like my numbers to end in 0, so the subtraction is very easy. 6 goes into 42 7 times. So 1,002 is 6 times 167. This is 2 times 3, 167. The first thing I would do is, it's a funky looking odd number. I think, let me use the 3 trick. 1 plus 6 is 7, 7 plus 7, 14. So 3 does not go into 14. And usually when I do this, I'll spare you from doing the whole thing. I'm going to go through the 11 trick, which is important, and then I can show you that why I know that this is still prime. But let's look at the 11 trick. Okay. The 11 trick ends a little like the 3 and the 9. So alternate positive and negative signs on over each digit. Sum together. Is the result a multiple of 11? And then 0 counts, okay? Because it's almost always 0. I'll show you in a second. But first, here, let's do one that does work, okay? Go up here. 187. I go plus, minus, plus. Common question, do I have to start with a plus? No, because usually you're either going to get 0 or negative 0. Or sometimes you get 11 or negative 11. So if you get negative 11, that counts as a multiple of 11. But look, 1 plus 7 is 8. 8 minus 8 is 0. So since it is 0, then I know that this is a multiple of 11. I mean, it tells you that it is, but it doesn't give you any help with the actual division. So I'd say 11 goes into this number. I know it's going to go in at least 10 times. 11 times 10 is this number. By the way, in the beginning, I wasn't that great at this. When I first kind of learned this method, it's a little tricky because you're doing it all backwards, but after your 6th or 7th time, you'll get the hang of it. And then 11 goes into 77 7 times. So I know that 187 is 11 times 17, 10 plus 7. Okay, these are 2 prime numbers. Okie doke. 167, I go plus, minus, plus. I get 8 minus 6 is 2. That's not a multiple of 11. So basically, like a lot of times I have to tell you that like if you go through all of the ones and you really, okay, after you really only have to really do the primes, but 2 and 3 and 11, and I guess 5, but you know that's not divisible by 5. Once you do 2, 3, and 11, if it doesn't go in, it's like 99% chance that it is not factorable. I mean, unless they're like really, really hard problems, and that comes into my special quadratics. But you know, because it's sort of like outside the edges of the universe, you do not have to keep going. The other way I actually can prove that, though, is I think of 160. This is another one I do. 167 is very close to 169. And 169 is 13 times 13. So if 167, this is how I'm proving that it definitely is not prime. If 167 is not prime, then it means that you have at least 2 bubbles. Like look over here, okay? Prime numbers are the ones that only have one circle, 2, 3, 5, 7. Anything that's not prime means that you have at least 2 prime numbers, like 10, okay? 5 times 11. Anything that has at least 2 bubbles. So if 167 is not a prime number, you're saying it has at least 2 bubbles. And it can't have both of these things above 13. Like it couldn't be like 17 times 19 because that would make no sense. This number is smaller than this. So what I really just have to think is all the prime numbers under 13, 2, 3, 5, 7, 11. And we know that this is not divisible by 2. We did the 3 trick. We did the 11 trick. It's obviously not 5. And then the one other thing, 167, if I had to do divisible by 7, 7 goes to 140, 27. Look, 7 doesn't go into 27, so 7 isn't in there. So now that I know 167 doesn't have any of these prime numbers, I am certain that 167 is a prime number. Okay? Anyway, that's a little thing. Okay, now I'm going to give you a question that relates to this. Okay? This is Yeah, this would probably definitely be a GMAT problem because a GRE students probably could use a calculator. But which of the following is divisible by 36? Okay, right away, divisible is a tip-off that this is number caterpillars related. Okay, I'm going to read these numbers out because sometimes my handwriting. 5,232. 5,742. 5,244. 5,364. 5,130. Okay, so some things, if you feel like you're doing no long division, that would take too long. That's got to be a tip off that's like heavy labor. Okay, there's something cute and clever about this, and it's related to the rules of divisibility that I just shared with you. And yeah, I'm going to tell you to caterpillar 36. Okay, that's going to be the hint. And you're trying to figure out if those pieces fit into these numbers and how to do that. Okay, so I'm going to give you 2 minutes to think about this. Oh, and I'm also going to say there's only one right answer. I was thinking one of my students came in here and for moral support. I think he's gone now. Okay. You guys think you have the answer? Please say yes in the chat. You can put your answer in the chat. I want to see what you guys think. Okay, cool. Here's the deal. Okay, so 36 is 2 times 2 times 3 times 3. And I think a lot of people go, 36 is divisible by 6, so I'm going to do the 6 trick. The 6 trick is to see which of them are even, and they're all even. And then what adds up to a multiple of 3. So adding this up, I have 12. Adding this up, I have 12 plus 6, 18. This is 10 plus 5. This is 18. And this is 9. So looking at all these sums over here, every single one of those is a multiple of 3. And every single number here is even. So that means that every single number is divisible by 6. Therefore, like the 6 trick doesn't really do anything. But the question doesn't ask if it's divisible by 6. It says it's divisible by 36. And when you think about a lot of people, I'm like, why did you pick, when my students get to this and I'm trying to pull it out of them, sometimes like, why'd you pick 6? And they're like, well, 6 goes into 36, or 6 is the square root or whatever, but 6 goes into 36. And then I'm like, okay, use that. What else goes into 36? And 4 goes into 36. Okay. So because 4 goes into 36, if you want to find a number divisible by 36, that's got to be represented. So 32 is a multiple. I'll keep that one. 42 is not. So B is out. 44 can stay. 64 can stay. 30 is not a multiple of 4, so this one's out. Okay, 4 trick eliminated 2. Then 9, okay? 9 has to fit in. So 12 is not divisible by 9, that's out. 15 is not divisible by 9. The winner is D, okay? There are other variations. I was talking to another tutor, and I remember when I was like, he said rules of divisibility. It's like, yeah, I do, like 2 through 12. And I was like, I don't do 12, but it is the same idea. 12 is 2 times 2 times 3. There's a lot of problems that will ask if something's divisible by 12. And what you're really asking is, is there a 4 and a 3? You want the tricks to be mutually exclusive. You don't want to do the 6 trick and then another 2, because the 6 trick involves the 2. So you're just kind of doing the same thing twice. Or 18. 18 is 2 times 3 times 3. You would do the 9 trick and you'd see if the number is even. Okay. So there's a lot of different things. I mean, if you're trying to do a number divisible by 24, it's the 8 trick and the 3 trick. That's really rare. If you've got this down, you're pretty good. But that's like one of the things I wanted to show here. Okay. I'm like a little nervous. There's something they do teach, and I've never taught it in a demo class, but I'm thinking maybe. How are you guys doing? Do you want a little bit more of this, more problems dealing with the number caterpillar, or do you want to learn another trick? I'll hear a vote. Okay. Another trick, please. I got 2 another trick, please. Okay. Okay. Okay, this is kind of high level, but I'm going to just do the easier part of this. I'm going to teach you guys how to find the number of unique factors of any integer, okay? And this is sometimes when I'm teaching this first day lesson and people are like, yeah, this is so easy. I pull this up and I'm not going to show there's 2 dimensions. I mean, this could be easy and hard. I'm going to stay away from the hardest part. But what I'd like you guys to do is set up your paper and write, this is the title of it, How to Find the Number of Unique Factors of Any Integer. And then along the right, please put out the steps. Step 1, caterpillar the number. Step 2, condense with exponents. Step 3, add 1 to each exponent. Step 4, multiply. And give you like 30 seconds, and then I'm going to do it for one number, and then I'm going to let you guys try it. Okay. Okay. So 180, we've seen this number a lot. So it's 2 times 2 times 3 times 3 times 5. That's the caterpillar part. Then condensing with exponents, 2 squared, 3 squared, 5 to the first. Okay. Now, after you've definitely condensed it, you look at the exponents and you add 1 to each. Now, the thing that people mess up the most is that you add, then multiply, add, then multiply. But so first thing I'm going to do is this is a 3, this is a 3, this is a 2. Remember that if, you're like ones, we don't always have to leave them, but for this you do. Oh, I mean, you have to put them up there. Okay, anyway, so now I'm just going to go 3 times 2, which is 18. And I don't know if you remember, but when I wrote all the factors of 180, I was like, there are 18 positive unique factors. And here you go, there are 18. And if you're like, Marie, I don't have to do this. I can just write them all out. It's not going to take that long. There are a lot of problems that will be like, how many factors are in 1600 or 8100? Okay. So, why don't you guys take some time to do them all out, and then I will just confirm at the end. It doesn't take that long. And if you're like, this is not that hard, I agree. I mean, going from step 1 to step 4 isn't so bad. It's when you have to start thinking backwards. I'm going to, yeah, well, whatever. Okay. So work through these because I have some observations to make. These numbers are picked deliberately, so I can make some observations about this. If you guys want to like put in the chat what you're getting for answers, just so maybe like other people see and go, oh yeah, that's what I'm getting too. That's fine with me. Usually at this point in the lesson, I start putting notes on my student. They're like calling them out so I can make sure they're understanding it. What'd you guys get for 1600? Anyone? Anyone? Bueller. 21 is correct. I'm gonna put that down here. I'm gonna do this in case anyone needs a refresher and didn't understand this. So 1600, I'm gonna say that's 16 times 100. 10 squared right away. That I know that there's gonna be 2 2s and 2 5s, and then 16 has 4 2s. So when I condense it, it's 2 to the 6th, 5 squared. I'm going to take the 6 and the 2. I'm going to change that to a 7. I'm going to change that to a 3. I'm going to multiply. That's how I got 21. If no one wants to like shout them out, I just need to know when you guys are done. I feel like I rush. I've always, as a high school teacher, I definitely didn't wait too much for answers. I'd be like, hurry up, hurry up. But, just tell me if you want me to go ahead. Okay. I'm going to give you guys one more minute, and then I'm going to go through all of them. Okay, 36. 36 is 6 times 6, 2 times 3, 2 times 3. So it's 2 squared, 3 squared, 3 times 3. There are 9 factors of 36. 8,100. Anything that's zeros, let me do this over here so I can explain. 8,100, or even like, sometimes I don't like when people, I definitely don't like when students go 1,600 is 2 times 800, 2 times 400. You always should use the idea that we work in the base 10 system. The number of zeros is the number of tens. And what I'm saying is like 8,100. I'm going to change that to 81 times 100. And that's the same thing as 10 squared. So I automatically know that there are 2 2s and 2 5s. If this was this would be 3 and 3. Okay. This 4 and 4. Okay. So 2 squared, 5 squared, 8,100. My students memorize this by the second class is 3 to the 4th. So 3 to the 4th, 5 squared, 2 squared is 5 times 3 times 3 when I add 1. So that's 45. There are 45 factors of that number. 32. 32 is 2 to the 5th power. You just add 1. There's 6 factors. 243 is 3 to the 5th power, also 6. I call these caterpillar cousins. It's not super important, but it's just a pattern. They have a similar structure, a body structure. They're prime number to the 5th power. 98 is 2 times 49, so it's 2 times 7 squared. And that is going to turn into a 2 and a 3 after I add 1. And so 2 times 3, also 6. Sorry, 2 times 3, also 6. And this one, 75 is 3 times 5 squared. And same idea, 2 times 3, also 6. These two are caterpillar cousins. Why? Because sometimes I like make it like a dangly earring. Okay. 98 is 2 times 7 times 7. And 75 is 3 times 5 times 5. And I picked these numbers deliberately because I wanted them to have no prime numbers in common. But if I asked you what they had in common, I mean, I'm like asking, like, if I was asking a 5-year-old, what do they have in common? I want them to be like, there are 3 circles, and there's 2 circles that are the same color, one that's different, 2 that are the same, one that's different. And it's not like something I need people to memorize, but it's just like pattern recognition that a prime number to the first, a prime to the first times a prime squared is always going to have 6 factors. And a prime to the 5th is always going to have 6 factors. This is sometimes when you have to do this backwards. I'm not going to do that now. But I do want to make some observations that are very important. I remember teaching high school once and talking and telling my students, look, you guys, when you factor a number like 12, I want you to do the outside inside. And they're like, Miss Bursick, we learned this in middle school. We called it the factor rainbow. And they'd go 1 and 12, 2 and 6, 3 and 4. Okay. And I remember standing up at the board, and I don't know why it occurred to me when I saw the rainbow, but not my method. I was like, there are 2 arches, or the arch, there's 2 sides to every arch. Every single number has an even number of factors. How come I never noticed this? And obviously that's not true, because look over here. 1600 has 21 factors, 36 has 9, 8100 has 45. So not every number has an even number of factors. Does anyone know what's special about what these 3 numbers have in common that make them have an odd number of factors instead of an even number of factors? And when I'm one-on-one with the student, they're like, I have no idea. I'm like, well, which number do you think would be the easiest one to explore? And we're going to say 36. And I go, write out all the factors of 36 and tell me why that is a 9 instead of an 8 or a 10. And by then they usually figure it out. So give you like 45 seconds here to see if someone can figure out what is special about what you call those numbers. Okay, that's the answer I'm looking for. 1600, 36, and 8100 are all perfect squares. And when you do like, 36, and you go 1 and 36, and 2, 18, 3, 12, 4, 9, 6, you're not going to count 6 twice. Okay. So the ones that they do pair up, okay, there's always this pairing up thing, but if it's a square root or a perfect square, so perfect squares have an odd number of factors. And if you get a clue that something has an odd number of factors, that clue is saying that the number is a perfect square. Okay? Okay. Let me finish up with one more problem. How many factors? How many distinct factors? I feel like this is grammatically incorrect. How many distinct factors are in the number 10,010? Okay. The number 10,010 has how many distinct factors? That sounds better, but that's the question I'm asking. And it builds off everything I've taught you, what I just showed you, and rules of divisibility, and the number caterpillars. I found this problem. I didn't make this problem up, but I found it in the back of a book, like some retail book that I used to use, and this was in their advanced section. And I always bring this problem into because it's like brings in everything. And I like the numbers that they use because it kind of emphasizes that I'm not lying when I say that you need to learn those rules of divisibility and know this trick. Also, I'm going to put this other one, and I don't think we have time for this, but if anyone wants another challenge, I think this is the hardest problem. I'm going to put this up, and I'm not going to answer it today, but if you want to send me, if you think you know the answer and you want to email me or text me and, through Leland, I'll confirm if you got it right. But we're still on this one. There's just, I see some people have finished up. So, how many integers between 0 and 900 inclusive have exactly 3 distinct factors. Positive factors. When you guys are ready, if you need more time, say more time. And if you want me to explain, say explain. Okay, how many distinct factors are in 10,010? I'm going to caterpillar this. And the first thing is, this is 1,001 times 10. This is 2 times 5. 1,001 is not prime. I mean, a lot of times my students say it is. I'm like, you think I'm going to give you something that easy? So you're going to go through the rules of divisibility that I taught you. 2, 3, 4, 5, 6, 8, 9, 10, and 11. That number is not divisible by 2. So no even number is going in. Because if a 2 doesn't go in it, then 2 2s doesn't go in it, then a 2 and a 3. I hope that makes sense. Add up the digits. It's not divisible by 3, so it's not divisible by 9. It's definitely not divisible by 5. But 11, 1, 0, 0, 1. If you go plus, minus, 1 minus 1 is 0. So 1,001 is divisible by 11. Okay, now let me just remind you like the old way you did this. You would be like, okay, 11 doesn't go into 10, but 11 goes into 100 99 times. And I'm just telling you to put zeros on that, okay? So 11 goes into 909, this number, 90 times. 11 times 90 over here. Okay, then I have 1, that, okay. And 11 goes into 11, 1 time. So 1,001 is 11 times 91. My favorite number, 7 times 13. So the caterpillar is, you don't have to put them in order, I just do to make things simple, is 2 to the first, 5 to the first, 7 to the first, 11 to the first, 13 to the first. I'm going to take all these exponents. I'm going to add 1 to each. 2, 2, 2, 2, 2, 2. And then don't add this. You multiply. So you're getting 2 to the 5th power. And that is 32. So this number, this number has, you know, if I were going like this, there are going to be 32. 16 on this side, 16 on this side. And that is, yeah, I saw that in the back of a book and I was like, oh my God, they even have my 91 in there. Okay. So you rule of divisibility for 11. These things are always coming up over and over. That's why I'm like, 11 trick is not extra credit. You need to know that all the time. They love that. Okay. And this is sort of the beginning of everything of how I show this. I hope you guys got something out of this. If you are interested in learning, I mean, I'm not going to like do the whole sully on how I organize everything. I just will say that in my former life, you know, I think I already said that I was a teacher. So I feel like I have a very organized, I know how to hold people accountable, and a little carrot, little stick, and kind of, you know, keep people. I have error logs for all my students and track their data. And I think I like one thing that I'm very good is being organized. And I always tell my students, this isn't about you, it's about me. Okay. Like I'm a very competitive person and I really push everyone to, you know, maximize it. I mean, I love this stuff. I obviously like quant a little bit more. I mean, I think I'm more of a quant person, but I do teach all subjects. My true passion is definitely this stuff. And this relates a lot. Like even the thing that I was showing you, how many integers there are in a number, that relates to combinations. So my favorite things really are number caterpillars. I mean, integer properties, number properties, and probability and combinations. Those are my favorites. Um, I'll just show you a little bit what I do with you're asking about that. Error logs is, I keep trackers and I assign worksheets for my students and then I make them put, like label them on a 1 to 4 scale. Okay, like this student does that so that they're color coded. And I make one of these for each of my students. And then there are test reviews. And Sophie is, I mean, she's like killing it because I mean, she also made a little scale of her own. I've had other students do this, that they change it. Like, you know, my scale is 1 to 4, but she made her own. And then I do test reviews. So like, this is like, you know, she talks about the test and then these are problems that she wants to go over. She kind of nerded it up in the beginning. And now it's like, sometimes like with verbal specifically, I ask my students to find the link from GMAT Club because the new MBA the what do you call it? The interface with their website blows. And every time I review the test, the answers are in front of me. So I don't like that for the verbal. So sometimes she'll find the links of the ones that she wants to go over. But I also want to show because here, let me see. She's one of like my I keep this so but I mean, like we started in December and her score, like this is like where she started. The second test is always, ugh, and she's already gone up like 130 points. And I mean, she's taking another test before MET. So these are like all the concepts. My first day, this is kind of what you got. And then these are other things that I start going through. I mean, this is sort of how I do it and then how I do my lessons. And they're always like very long in the beginning and all the topics I cover, whatever. Obviously, I'm crazy my organization because I will make this work whether you like it or not. Okay. If you hire me, I'm going to drag you through this, but I'm going to make you love it. Okay. Because I don't know, I think it's fun. And I like that color coding stuff. And I like when students are like, oh my God, this is actually kind of fun. When I get that, I feel like I've got them hooked. People are more motivated. Um, Anyway, so that's error logs is all kinds of stuff. But, you know, my system is my system. I'm sure other teachers have theirs. I don't know. This is what works for me. I think we are pretty much at the end. If you know, I think you guys know how to find me. Um, and if yeah, Amanda's putting up my profile if you're interested in booking a call and talking about this. Oh, I want to say one thing. I was going to talk a little bit about like the different ways, you know, sometimes people ask me about courses and what I think is good and what isn't. Um, I am not a big fan. I mean, private tutoring just really is the most efficient way for someone. Like, I'm looking into your brain and trying to figure out problem solving is like a corn maze, and I have to figure out how to, like, leave breadcrumbs to pull you out, and so you can figure out the problem. I'm not just teaching you math. I'm trying to teach you how to think better. And for the most part, like I did work for Kaplan teaching those big courses, and I've had a lot of students who have done an entire Manhattan prep course or TTP. And I do like TTP, but it's a little bit like trying to take a sip of water from a fire hose. People do it and they're like, okay, they come to me because they can only get through like 20%. The courses and the boot camps that I've talked to the other, like the tutors here are people who are like me. We've worked for some of these companies and we know that we can do it better. And I don't think I could really teach a course because I really like the interactive stuff. But I know the people who are teaching the courses, and this is the best bang for your buck. It's cheaper than the other stuff, and our our tutors are just better. I mean, like a lot of, I know how I started, and I basically took Kaplan gave me like a weekend course to read word for word a script. And after, a couple years of doing that, I'm like, I want to do my own script that I write and not this. And there are, I've talked to Bruce, who I know does it, and he's like, he did it at UCLA. He feels very confident doing it. I mean, tutoring is always the best, of course, but we've got the best. We've got the best program. So I'm telling you, I get nothing out of this. Okay, I get nothing out of this. Not even like a little certificate or anything, but I'm just telling you, you're in good hands if you do one of the boot camps. You might need a little extra, but it's definitely going to give you a good foundation. Anyway, I think I'm done. I don't know if anyone's here to take this over, but officially we are yeah, closing this down. Okay.
Thank you so much, Marie. Really appreciate it.
You're welcome. Hope everyone liked it. Take care. Bye.
Thank